Yeah, podium. Okay, so better like this. So Pierre Dissaux, Ellidiss technology. Ellidiss is a small French business, small, but we have been involved with ADL since I created the company 15 years ago, in fact. So we have mostly three activities. The first one is about the hood design methodology. Hood is something that was invented by the European Space Agency a long time ago and has been applied by many European projects, especially the Eurofighter Typhoon, the Airbus family of civilian aircraft, A380 and 50, and the Tiger helicopters and many others. In addition to that, we have invested a lot in AADL tools, especially with two tools. So we have adapted one of our design tools from Hood to AADL and made some additional work on AADL verification with another tool, which is AADL Inspector. And finally, we also work on well, we are tool vendors. We work on tool technology, so we have specific technologies, especially on model processing, on ADL model processing. This is called LMP. So I like to present our tools that way, with front ends and back ends connected together by a logical bus, which is in that case ADL, the ADL standard. So we can, on the front-end side, obviously use our design tools to try ADL, but we, as you know, if you heard here, you can use many of the other tools that has been presented today. ADL Inspector, that is the gray box at the middle, includes some front-ends and back-ends. On the front-end side, you can, well, there's a texture editor on the project management tool. But you can, like everybody is trying to do today, try to convert SysML to ADL. So as opposed to others, maybe we don't provide a turnkey SysML to ADL solution, because we have observed that there are so many variants of SysML models that are existing by customers that it's very difficult to set up a unique and well-defined mapping between SysML and ADL. So what we provide instead is a framework and on the solution to help you to build this mapping and implement it with our LMP solution. On the backend side, we've got a set of analysis tools. Most of them are not developed by ourselves, but just connected or integrated. Some of them are developed by universities or partner companies. We do some part of the work, obviously, ourselves anyway. Finally, at the bottom of the picture, you can see other tools that we are developing that are more domain-specific solutions, because not everybody wants to model his system directly in ADL. So they may want to use more specific modeling languages on tools. One example of that is the TASTE toolchain that is developed by the European Space Agency. So they defined a front end in terms of diagrams that they want to use on top of processing. And we just use ADL as a kind of hidden formal solution to link these front-end tools to, in that particular case, to the Ocarina code generator that Jerome knows quite well. So it is another way to use ADL that is not exposing it directly to the end user. A few snapshots. Stud for ADL, so design tool. The benefit of Stud as opposed to other ADL graphical editors is that we get all the benefits of this Hood industry-proven methodology with project management and a way to add very informative data structure to each ADL component to add documentation on this kind of thing. ADL Inspector, that has been mentioned already several times today. It's a verification framework. So there we import AADL, and we can plug various analysis tools in terms of real-time performance, safety, security, and whatever. Just an example that I will be able to run on the demo part of the day. Just starting, for instance, from modeling in STUD of a typical control system. So graphically with additional information given in the detailed design part. From the complete STUD model, we can generate directly the AADL specification without having to add anything more. So this gives some AADL, some textual AADLs that can be loaded into AADL Inspector with all the various annexes and properties you may want to add for the purpose of the analysis. So in terms of analysis, if we focus on real-time performances, for instance, you will be able to run your AADL specification without having written a single line of code. So it's thanks to this simulator, we will use the AADL runtime semantics and be able to run your system, show the various software running on the various processors, the bus communication, and so on. This is also used to collect real-time information in terms of actual response time for threads, for instance. All that can be compiled onto various tables and used, for instance, to compute end-to-end flow latency analysis. So this computation can be customized thanks to our internal verification language. It is called LAMP. It's a new annex for AADL. And feedback onto the real-time properties that can be, and you can come back to your AADL specification and loop as many times as you want. In terms of safety analysis, we are just using a tool that we didn't develop at all. It's just a connection with a remote tool. So on our side, the only thing we do is interpret the AADL error modeling annex and generate an XML file using of this OpenPSA standard that can be fed by another tool to build the fault tree analysis and so on. On safety analysis, we don't have a specific remote tool to provide these results. We are directly using our LAMP verification language that is fully integrated into your AADL specification. So for instance, if you can extract and formalize your security policy in terms of rules, we have a process to translate that quite directly into LAMP statement, just to say that LAMP, in fact, is directly using the Prolog language, the standard Prolog language. So that's something that we have fully invented. What we provide is an encapsulation of this Prolog language directly into an AADL specification with a full access to all the AADL modeling elements of your program. So you can translate directly your security policies. The same, it may vary quite a lot from a project to another or a company to or another. So we provide a programmatic way to support that. And then we will be able to run interactively these rules and provide an immediate result, so letting you the ability to look back again. A word about what is done by our colleague from the university close to Ellidiss. So it is the University of Bristol and the Lapstick lab. They are working on schedulability analysis. They are developing the Cheddar tool that is integrated into AADL Inspector and now into OSAT too. And their current work is really focused on multi-core schedulability analysis. Just to summarize, well, we are a commercial company, so we attempt to sell our tools. STUD for AADL, AADL Inspector that I presented and I can, of course, demonstrate this afternoon. We've got some technology about tool integration and to build various model transformation and so on. It is called LMP, and now LAMP, that is the same but integrated as an AADL annex. And we obviously provide all the services around these tools in terms of customization, training, on whatever you want, plus, of course, quite a lot of R&D activities. So thank you very much.